All right, for Bryce, you should have got minimum 80. Q1 was 81.5. Median was 90. Q3 was 98.5. And max was 100. For Brianna, stick with my color pattern. Brianna, her minimum was 89. Her max was 90. Her median was still 90. So Brianna had the same median. Her Q1 was 89.5, and her Q3 was 90.5. So Bryce is going to go from 80 to 100 with a median at 90, Q1 at 81.5, Q3 at 98.5. And Brianna, really close together. We got 89, 90, 91, and somewhere in the middle of those two. All right, so there's our two box and whisker plots. Two box and whisker plots. Number 2, based on your display, write down which of the two students you think should get the math award. Which of the two students do you think should get the math award? So, based on what we've done so far, who thinks Bryce should get the math award? Cash? Jordan? I don't have either one. Andrew's not sure. Bailey said Bryce. That's not right. Baylor. That was close. I'm sorry. I'm really sorry. Who would pick Brianna? Most everyone else would pick Brianna. Why might you pick Brianna? Noah? I thought stayed in the same area. She guys stayed in the same area. Bryce was what? He was like up and down. Bryce was kind of up and down. Like Bryce had a really good day. He made 100, but he also made it 80. But Brianna stayed pretty consistent, right? So with Bryce, okay. So with these numbers, we really need to be careful about trying to compare things if we only look at the measures of what we call the center, like the median. The medians are exactly the same. So based on the median, who gets the award? They're equal. Did anybody actually look at the averages to try to figure out who they would pick? They're both 90. So if we look at just the averages, I can't really decide based on the averages either because they're both the same. So in math with data, not only do we need to worry about like things that measure the center, like the average, but we also need to worry about a number. There's a number we're going to find today that would actually measure how spread out the data is. Is the data really, really closely compacted like Brianna's? Or is it like more spread out like Bryce's? Like he had 100, a 98, and a 99, but he also had an 80, an 81, and an 82. So his was definitely more spread out. And that's what we're going to look at today. This is kind of our new stuff today. The variance and the standard deviation, you do not need to know these formulas. I'm not even going to really refer to them. We're going to use them twice, but then we're going to find everything else on the calculator. Because imagine what we're going to be doing. We're going to be doing it with 8 numbers. A lot of times we have a lot more than 8 numbers in our data. We might have 1,000 numbers or 2,000 numbers. So to do this by hand would be really, really tough to do it by hand too. Very, very tedious. So number 3, we want to calculate the average or the mean for Bryce's grade. And somebody already told us that that was 90. You can find that the same way we found it yesterday. On your calculator, you're looking for the X bar. And on Desmos, you would hit the mean. So you go to stats, you would find the button that says mean, and you would put your list inside the parentheses there. And it would automatically calculate the average or the mean for you. So now we want to fill out this table to help us calculate the variance. The variance and the standard deviation is just a measure of like how does the data vary? How is the data distributed? Is it close to the mean, or is it like really far spread out away from the mean? And in order to find that, the first thing we need to do is to take each of our data points, so that's just that xi piece, each data point minus the average. So Bryce's first data point, he made a 90 on the first test. We're going to subtract the average, which is also a 90. So what does that give me? 0. So if his average was a 90 and he made a 90 on the test, how much did he deviate from his average? 0. That's why we get 0. So 90 minus 90 in this second row would also be 0. He deviated from the mean 0. Like it was the average. His test score and the average are the same in that case. What if he made the 80 on the test though? How far away from the mean is that 80? 10. But it's under, so like lower than the mean. So it would actually be negative 10. So just by subtracting now, we're trying to kind of figure out how far was each test away from his average. We're just going to do that with each test. So 100 minus 90 is positive 10. 99 minus 90 is 9. 81 is 9 below the average. So we do get a negative there. 98 minus 90 would be 8 above the average. And 82 minus 90 would be 8 below the average. But if we're trying to measure, like, on average, how much did he deviate away from his mean? What happens to all of these numbers? If we add them all together, what happens to all of them? We got a 10 and a negative 10. We have an 8 and a negative 8. They all cancel out. So what would all of these numbers add up to? 0. So if all those numbers add up to 0, can we try to figure out, like, on average, how much did one test deviate from his mean of 90? No, because they all added up to 0. So we got to do something else. Because typically, if we were to do this, they would all add up to 0. Even Brianna's test scores in a little bit are going to add up to 0. And I can't compare 0 with 0. 0 and 0 are the same, so we got an issue. So mathematicians, statisticians saw this issue. And they're like, man, how can we measure how spread out these data points are? Well, what if we made them positive? What if we made all of these numbers in this column positive? And there's 2 ways we can do that. The first way is just to take the absolute value. And you guys did that in Algebra 1 when you found something called the mean absolute deviation. Maybe you heard it called the MAD. Maybe you remember doing that. Well, I hate to say this, but people really don't use the mean absolute deviation outside of math class. So like in real life, if I were going to go measure how spread out some data is, we're not going to use the mean absolute deviation. We're actually going to use the standard deviation. So mathematicians said, well, what's another way that we can make all those numbers positive? And the way that they came up with was to square those numbers. So take like a negative number and multiply it by itself. What kind of number are you going to get? You're going to get a positive number. So that's what they did. They took these and they started squaring all these things. Like 0 squared was 0. 0 squared was 0. Negative 10 squared is positive 100. So now we've made all these numbers, they're bigger, but they're also now positive. So 10 squared is 100. 9 squared is 81. 8 and negative 8 squared is 64. Now if I add up all those numbers, do I get 0 anymore? No, we don't get 0 anymore. And to save some time, I'm going to tell you what we get. We actually get 490. So now we can take this number and we can say, okay, on average, like what's the average of these numbers in this column? Well, how would we find that average? We would add them up and divide by how many numbers we have, right? So we added them up, we got 490, and we're going to divide by how many numbers we have. And we have 8 of them. So 490 divided by 8 is 61.25, I think. I had my answer key earlier. There it is. Should I just double check? Yeah, 61.25. So on average, these numbers are 61.25. But what did we do with those numbers? We squared them. How can we kind of take that number and like maybe undo squaring them? We can take the square root, and that's what they're going to do here. So to make these numbers smaller, maybe back to like this column, but not quite this column because they were negative, we can take the square root of this number. So the standard deviation, what we're learning, this is our focus today and tomorrow, standard deviation. It is the square root of the variance. And the variance is the number that we just found, the 61.25. So when we take the square root of 61.25, we're now going to get a number that is much smaller because we squared all those numbers. So we ended up with numbers that were much bigger. And we get 7.826. 7.826. So what do these measures tell us about Bryce's grades? For now, we don't really know a whole lot because we only have one number. But if we had another number, maybe Brianna's standard deviation, we could look at those numbers and say, hey, I know that Bryce's data is closer together or more spread out because his standard deviation is bigger or smaller than Brianna's. But we don't know Brianna's standard deviation yet. We will soon. So basically, all of these values, all they tell us right now is these values tell us how the data deviates from the mean. These values tell us how Bryce's data, the data, deviates from the mean. Deviates from the mean. Now, the larger the standard deviation, the more deviation from the mean, the more spread out those numbers are. The smaller the standard deviation, the closer those numbers are going to be grouped together. So we already know what Brianna's numbers are. She had a lot of numbers between 89 and 91. So when we find Brianna's standard deviation, what do we think it's going to be compared to Bryce's? Lower. It's going to be lower, probably a lot lower, because Bryce had a lot of variation, but Brianna didn't have much variation. So Brianna's standard deviation is probably going to be much, much lower. So we're going to fill this table out one more time. This is the last time you have to do this by hand. We're going to do it fairly quickly because we're just subtracting and squaring numbers at this point. So 90 minus 90 is, her average was 90. 90 minus 90 is 0. How much deviation is there from the mean? None. 91 minus 90, she's 1 above the mean. 89 minus 90, she's 1 below the mean. 91, she's 1 above. 89, she's 1 below. 90 is the mean. So there's no deviation for 90. Well, what happens if we add all those numbers in that column up? What do we get? 0. So again, mathematician was right. That's a problem. I can't calculate how much deviation there is if this is all I do. So the standard way is to square those numbers. So then we take all of these numbers and we square them. 0 squared is 0. 0 squared is 0. 1 squared is 1. Negative 1 squared is also 1. 1 squared is 1. Negative 1 squared is 1. 0 squared is 0. Now, when we add those numbers together, we don't get 0 anymore. We actually get 4. And some of you might be asking, like, why didn't we fill out this column? We don't really need that column, so don't worry about it. I know it's there, but we don't really need it. All we really need is this number right here, and then we're going to take the square root of that number after we divide by 8. So her variance, if we add all those up, we get 4. She took 8 tests. So 4 divided by 8, her variance is 0.5. A lot smaller than Bryce's variance. Bryce's variance was like 61 or something. 0.5 is a lot smaller. So just by looking at the variance, we know Brianna's data is a lot closer together. But if you go look at a report or a newspaper article or a magazine or a Twitter post or something, they're not going to report the variance. They're not going to tell you what the variance is. They're going to tell you what the standard deviation is. So to find the standard deviation, we're going to take the square root of that, which is 0.707. 0.707. So what does this tell us about Brianna's data? Well, it tells us how much deviation there is, but compared to Bryce, it tells us what? Yeah, Brianna's data is much closer than Bryce's. So both of these numbers tell us that Brianna's data, or her test scores, is much closer. Much is a C, much closer than Bryce's. Is much closer together than Bryce's. All right, number 9. Using the average and the standard deviation. Which one would you pick to receive the award? And your justification is going to include words like the average, which the average was the same. So maybe you don't really have a big argument there with the average. But maybe use the words standard deviation. Like, hey, Brianna's standard deviation is larger, or maybe Brianna's standard deviation is smaller. Therefore, her scores are more spread out, or therefore her scores are closer together. And this is why I would choose Brianna to get the award. Okay, so not only do we need to like talk about the math that we learned, but we need to be able to use it to maybe justify why we might pick Brianna or Bryce to get the award. And then once you answer number 9, there's one more thing I want you to add at the bottom of your notes, and you can just copy it exactly like it looks. So do number 9 first, and then write this down. And we're going to have a discussion about those two things. Man, I got done super early today. All the other classes still way longer. All right, so answer number 9. Yeah, this class, like all the other classes I got done, there's only like 5 minutes left. But we got like 15 minutes left in this class, which is good. I'm not complaining about that. What do we do with small class? You're just going to write this down. We're going to talk about it in just a second. You're just going to write on your paper, somewhere on your paper, anywhere. I don't care. On the front, on the back, it doesn't matter. But we do need to be able to differentiate between the population, SD stands for standard deviation, and the sample standard deviation. Remember back like last week, maybe the week before, we talked about population and samples, and we said numbers that describe a population, we call those parameters, and numbers that describe a sample, we call those statistics. We would call that a statistic. Well, here's our first example of a number that describes a population versus a number that describes a sample. If I'm finding the population for, if I'm finding the standard deviation for Bryce, is the data I have for Bryce the population or a sample of the population? How many tests did Bryce take? He took 8 tests. How many test scores did we use? We used all 8 of them. So in that case, we have the population. That data is representative of a population. So in this case, we actually found the population standard deviation. And these two numbers are actually a little bit different. So in your calculator, go back and do the one variable stats on Bryce's data. Go back and do the one variable stats on Bryce's data. So go back and do the one variable stats. And likely your data input will be L1 this time. You should see a couple numbers. You should see N. It should say N equals 8. It should say X bar equals 90. What are the next two? S comes next? So S, X, and then this little symbol I drew. This little symbol, it looks like a cursive O or something. but it's actually a lowercase sigma, which is a Greek letter. And in our notes, when we talked about parameters and statistics, we said, hey, parameters are going to be identified with a Greek letter, and statistic, those about a sample, will be identified by a English letter, a Phoenician letter from the Phoenician alphabet. So which one of these two would we use for Bryce's test scores? We would use the population, which is actually the Greek letter one. So those two numbers are standard deviation, but you do need to know when to use which one. You do need to know when to use which one.